Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. So today we're going to be continuing the series on deriving or differentiating trigonometric functions using the product rule. And in today's question, we're going to be doing the fifth question. But before we start, I want you guys to, if you're new to this channel, I would advise that you copy down what is currently on the screen on the first page, where these are just trig notes. Students who are consistently following this channel and understand it's a series, majority of them copy these notes down so that they can use it for the different derivative rules. So I would advise that you have these notes as you go through the series. It will be very helpful for you to have for both differentiation, derivative, chain rule, quotient rule, all of that stuff. It's going to be very important for you to basically have this page. So please write it down if you don't already have it. But if you already have it, then basically continue with me as we go on to the video, or go on through the video. So in this video we have the question f of x. We have the question f of x equals sin x cotangent x. So now the first thing we have to do is to review what the general formula for a function that we need to apply the product rule is. So the first thing you have to do is, whenever you have a function that has two subfunctions multiplied by each other, so two subfunctions f of x and g of x, this is what the general formula looks like. We can see that the question we have, sin x multiplied by cotangent x, is very similar to this general formula. And in order for us to do the derivative of a question like that, we have to apply something called the product rule. And when we apply the product rule, we end up getting the derivative of the first subfunction, in this place small f of x, right, small letter f of x, multiplied by the second subfunction by itself, g of x, plus the derivative of the second subfunction, in this case f of x, multiplied by the first subfunction, small f of x. And that is really it. And whatever we do, we're just going to add them up. So that is the understanding. So we already know, okay, this looks like the general formula where we're going to apply the chain rule. Sorry, not the chain rule, the product rule. So now what we have to do is, let's start solving, right? So if we start solving, we're going to compare our general formula with the actual question we have today. And we have the first subfunction f of x to be sin x, the second subfunction to be g of x to be cotangent x, right? So the first subfunction is sin x if we compare these two together, and the second subfunction is cotangent of x. Now that we have that, we can now input it into the product rule application formula. So we have the derivative of sin x cotangent x. And I wanted to mention, if this is the first time in this video and you have any question on this first time on this channel, or you're a returning subscriber, please just put it in the comment section. This video is continuous and I make sure to check my comments. So if you guys have any questions so far, please put it in the comment section and I'm going to be answering the questions as best I can. So the derivative here of the first subfunction, in this case we know the subfunction is sin x. Now we have that, then we multiply by the second subfunction, underderived second subfunction version, plus the derivative of the second subfunction, which is cotangent of x, multiplied by, and I use the dot to represent multiplication. In calculus, instead of using the cross, like the cross sign that looks like this, the X sign, to represent multiplication, we use a dot. And we do that because if we have so many X's, and people who are learning and even people who are doing their own calculations themselves can get confused as, are we using X? Are we using X? Are we using cross? What is going on? Is this a multiplication or is this a variable? We don't want that confusion, so we just use the dot. So in case you're confused, that's what the dot represents. It represents multiplication. So that's that. So now, the derivative of the second subfunction multiplied by the first subfunction, f of x, small f of x, in this case, sin x. So now that we have that, we can proceed as we solve. So now, what is the derivative of sin x? Derivative of sin x, if we go to the previous page, we see that the derivative of sin x right here, this information in red, all the information in red represent derivatives. Everything else in blue represents either trigonometric identities or trigonometric expressions. Anything that is in blue, the stuff in blue to the left, involves trigonometric expressions, and basically trigonometric expression as well as tips to be able to remember them within the formula. And then the one to the right up top is trigonometric identities, and everything in red is derivatives of trigonometric functions. So in this case, we're asked to do the derivative of sin x. We see that that is cosine x, so we can just input it on the next page. So in this case, we have cosine x, right? Then multiplied by cotangent x. Since we're not doing anything with the cotangent x, it just comes down here, and we just do plus derivative of cotangent x. What is that? Derivative of cotangent x. Let's look for cotangent x. Oh wow! Negative cosecant square x. Interesting. So we have negative cosecant square x, right? Multiplied by the sin x that is here. We just drop that sin x down here. Now, let's go to the next page. We're just going to rewrite what we had before. We have cotangent x, right? Cosine x minus cosecant square x sin x. Now, let me show you something I did. You see you have a positive sign here in this place, and you have a negative sign. When they come together, we end up getting a negative. So basically the negative dominates. This is just simple like math you've been doing since middle school. So that is what we have. So now our answer is going to be cotangent x, cosine x, minus cosecant square x, sin x. Now I want to mention something to you guys. What you've done so far is absolutely alright. This answer is good, but whenever you're dealing with trigonometric function, and just as mathematically, you would realize that it is best for you to simplify anything that you're doing. You always like to simplify the results. You don't always have to, but it's better for you to simplify whatever results you have. Simplify by factorization, by canceling out things. So in this particular case, we're going to try to simplify, because why not? Let's make our work as neat as possible. But if you have this as your answer, that is okay as well. But just me, personally, I love simplifying and factorizing, and I think it's going to be good for everyone to try to adopt that as much as possible, because that's going to be very helpful to you. So now you have cotangent x. Cotangent let's go to the previous page. Now, we have cotangent x, right? And I explained to you that this is also a trigonometric expression. What do you believe, or what do you know cotangent to be? Well, cotangent is basically 1 over tan of x. Cotangent is also cosine x divided by sin x. You can see. So we're going to pick one of these two. Because we're trying to cancel things out, we realize that we do not in any way, shape, or form have any tan information in this work, so we don't confuse ourselves. So we pick the other one, which is cosine x divided by sine x. So let's do cosine x divided by sine x, and that represents the cotangent x multiplied by cosine x minus, now you have cosecant square x and sine x. Now let's go again to the previous place. I want you guys to see something again. When you have, what we had before was cosecant square x, right? Now, when we go to the page here and we're trying to compare what cosecant is or cosecant square x is, basically we know that cosecant is the same thing as 1 over sine x, and we're trying to like cancel stuff out, or we're trying to simplify our work. We just come back here and we say, we do this instead. We have 1 over sine x is the same thing as cosecant x. But what of cosine x squared? That's the same thing as 1 over sine square x. Okay, so we have that down. And that multiplied by this one here, which is sine x. So when we do that, we just do the basic math. We cancel this out. So what we end up with is, when we write the full thing out, we end up with cosecant x, okay, and cosecant square x, okay, minus 1 over sine x. But no, it's not just cosecant square x, we also have the sine, so it's going to be cosecant x divided by sine x. Okay, when we do that, we can bring out sine x and do this. We can bring out 1 over sine x. When we bring out 1 over sine x, I'm sure you guys are beginning to see what is going on here. You can see you have cosine square x minus 1. You see what we've done here? So this is our answer so far. But then again, work is not done still. We still haven't gotten what we want. So let's go back to the same trig identities for me to show you something further. You see now, sine square x plus cosine square x equals 1. If sine square x plus cosine square x equals 1, then we can try to put it in a form that is going to fit our work. So sine square x plus cosine square x equals 1, right? So in this case, we can have, if we're trying to represent this, we can also have this to be cosine square x minus 1, because we bring 1 over, I bring 1 to the left across the equals to sign, so we have a negative 1, and then we bring sine square x, we take it to the other side, it will be negative sine square x, because we're bringing it over to the right, right? So negative sine square x. So therefore, the 1 over sine x that we have here, right, is the same thing as negative sine square x. Okay, so when we go to the next page, we have 1 over sine x is the same thing as negative sine square x. And to be able to continue this, we already know that we can cancel stuff out, this, and we can cancel this out, and our answer is going to simply be negative sine x. So therefore, the derivative of sine x multiplied by cotangent x is negative sine x. That is our answer. You see how we had our answer at first to be this information here, right? This is the answer here. This is an answer. This is an answer. And this is also our answer. But I would advise you guys, as students who watch my channels, who watch my videos and on my channel, please always try your possible best to break it down. Always try your possible best to break it down. Make your work easier, make your life easier. Try to make your teacher's life easier. Now I'm going to teach you guys a shortcut so you don't have to go through this whole process, right? Now the shortcut method is you're asked to do the derivative, right, of sine x multiplied by cotangent x. One thing you can do if you have a multiple choice question and you don't have time to always break down information, or a shortcut where you want to know whether the work you did, the long process works, is for you to remember now you have sine x. How else can we break down sine x? We can break it down further. Sine x can either be sine x or 1 over cosecant x, but we don't have to make it more complicated, so we're going to stick to just keeping sine x. But then we have cotangent x. What did we say cotangent x is? We saw that cotangent x is the same thing as 1 over tan x cosine over sine x, right? This information right here, this one. So you could have just said cosine x over sine x, right? That was my bad, sorry. 1 over cotangent, the derivative, gosh. Cotangent x can also be known as cosine x over sine x. So we put that in here. And we have cosine x over sine x. And we just do this simple math we've always been taught. Just cancel out. Cancel this out, cancel this out. The derivative of cosine x, oh my gosh, is the same thing as negative sine x. We know this. If you guys have been doing calculus for a while and you've already got into product rule, you already know that the derivative of cosine x is always negative sine x, and the derivative of sine x is always cosine x. And that is basically what we got here as the answer. You did not have to do this whole process. These 3 pages, 2.5 pages worth of work. You could have just done everything in 1 point here and you would have gotten the same answer. And here is the confirmation. What is the derivative of cosine x? It is negative sine x. So now this is the end of the video. Hopefully this video was helpful to you guys. If there are ways that you would like this video to be done and you have suggestions, please put it down in the comment section. If you want more information about my tutoring sessions that I do for regular everyday students, personal tutoring sessions, go into the description box. You get my contact information. You could also email me. My contact email and all of that is also in the description box. And if this video was helpful, please subscribe and make sure you continue watching the videos in the series. It's going to be there on the end screen as well as in the description box. And I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.